Hello and welcome to Normally Distributed, where we learn about statistics and probabilities with a sports twist. Today I am bringing you part one of calculating and interpreting probabilities. Now, as you may or may not know, probabilities are everywhere in life, from a weather forecast that says there's a 60% chance of rain to Stephen Curry shooting 90% from the free throw line, or Bryce Harper, whose batting average is .312. Probabilities are going to be everywhere in life, and it's essential that you understand how to interpret them and estimate them for fun. So, what is probability? Probability is a number between 0 and 1 that tells us how likely an event is to occur. So, going back to the previous examples, we have a 60% chance of rain. Bryce Harper's batting average is .312, and Steph Curry on average hits 9 out of 10 free throws. These are all probabilities, and these are all things that you'll see in everyday life. But what's interesting and what you'll note here is that there's plenty of ways to write a probability out. You can use percentages, 60% chance of rain. You can use decimals like we did in the Bryce Harper example, or you can use fractions, and they all mean the same thing. 9 out of 10, it's the same thing as saying 90%. It's also the same thing as saying 0.9. And in probability, these are all exactly the same. All right, great. So we have the definition of probability, which is that it's a number between 0 and 1 that tells us the likelihood of an event occurring. But what does that actually mean? What does 0 and what does 1 mean, and what is everything in between? Let's go ahead and look at our probability scale here. And on the left, we have a probability of 0. And that means that this event is absolutely impossible. This will never happen. And I can guarantee you that one event that you will never see happen is you will never see a T-Rex, a living T-Rex, on your way home. And on the other side of the scale, we have a probability of 1, which means that the event is absolutely certain to happen. And one example of this is that we have an absolute certainty that the sun will come up in the morning. Now, what about everything in the middle here? You see right in the middle we have a 50-50 chance. It's equal percentage that the event will happen and that the event won't happen. Think of this like a coin toss. When you toss a coin, there is an equal chance it comes up heads as it comes up tails. All right, so now we have our bearings straight on the probability scale and some of the major markers: impossible at 0, equal likelihood at 50%, and 100% certain at the 1 mark on our probability scale. Now, what are the rest of the areas here? They're just varying degrees of either certainty or uncertainty. To the left, between impossible and equal, we have the unlikely region. Now, these are events that have a chance of happening. They're not 100% impossible, but they are unlikely. One example of this is whether or not Bryce Harper will hit a home run when he goes up for an at-bat. Right now, he is averaging 2 home runs for every 100 at-bats, which gives us a probability equal to about 2%, actually exactly 2%. And so we would say that the chances of Bryce Harper hitting a home run are going to be unlikely. So let's go ahead and put our little baseball guy down here on our scale about 2, right around there. Now, on the other side of the spectrum, we have events that are likely to occur, and that goes right around here. An example of this, let's go back to Steph Curry. He shoots 9 out of 10 free throws, and he makes those. So he has a 90% chance of hitting a free throw whenever he goes up to shoot. And so that makes Steph Curry of hitting a free throw a very likely event. So let's go ahead and put that basketball right around there. And that's how probability works. And that's what the scale of 0 to 1 means. All right, great. Now we know what probability is and what the varying scales are. But how do we find probabilities ourselves? How can we estimate probabilities? And one way to do this is through a chance experiment, which is the process of making an observation when the outcome is not certain. Let's go through an example. Let's say we wanted to find the probability that a pitcher throws a strike. We can set up a chance experiment where we watch the pitcher throw, let's say 100 pitches in a game, and we count the amount of strikes in those 100 pitches. This is a chance experiment, and each outcome is what happens after every single pitch, whether it's a strike or not. All right, so we have our chance experiment set up. We've watched a pitcher throw a bunch of pitches, and we've counted up the amount of strikes. Now, how do we figure out the probability? And so we can estimate the probability of an event occurring using this formula here. And what you'll see here is this means probability that an event will occur. So in our case, it would be the probability of a strike. And that is equal to the number of observed occurrences of that event, or in other words, the number of strikes that we count, divided by the total number of observations. So let's go back to our example of the pitcher. Here we have a list of his pitches. We'll just do 10 for now so we don't have to count 100 of them. Let's go ahead and count the first one and calculate the probability that the pitcher will throw a strike, given that we have 10 of his pitches in the past. Now we'll see here we have 1, 2, 3, 4, 5, 6 strikes. So that gives us 6 observed occurrences, and we have 10 total pitches thrown. So that gives us the probability that this pitcher will throw a strike is equal to 60%. All right, let's go ahead and do this again. We watched another 10 pitches from the other pitcher, and we saw that he threw what looks like 5 pitches for strikes out of 10 that he threw. So that means that this pitcher throws a little bit less strikes, and so you can say that his probability of throwing a strike is 50%. So in the case of these pitchers, the top one seems to throw more strikes, and so we'll say that it is more likely that this pitcher throws a strike than anything else, whereas the other pitcher has an equal chance of throwing a strike or a ball. And that's a chance experiment and estimating the probability. Thank you for watching. This has been Calculating and Interpreting Probabilities Part 1. For some extra resources, please check out our website. If you liked this video, hit subscribe or like. If you have any questions, please feel free to leave a comment.